When a fluorescent light is turned off and an older electrostimulus machine connected to the same circuit is shocking patients, several factors could be at play. Firstly, let's consider the possibility of an inductive kick. When the fluorescent light is switched off, the inductive ballast within the fixture can generate a voltage spike. This spike can then propagate through the electrical circuit, causing voltage fluctuations at nearby receptacles. The older electrostimulus machine, given its design, might be more vulnerable to these voltage spikes compared to newer models. Secondly, a loose neutral connection is a potential culprit. A compromised connection in the neutral conductor can lead to voltage imbalances throughout the circuit. When the light is turned off, the load on the neutral conductor decreases, which in turn can elevate the voltage on the phase conductors, nominally 120 volts. This increase in voltage could be the cause of the shocks felt when patients interact with the electrostimulus machine. Thirdly, a ground fault should be considered. A ground fault within the circuit can cause the voltage on the neutral conductor to rise unexpectedly. This elevation can result in voltage fluctuations and present electrical hazards at the receptacles, potentially leading to shocks. To diagnose and resolve the issue, several steps can be taken. 1. Check for inductive kick. Use a voltage meter to precisely measure the voltage at the receptacle both when the light is on and when it is turned off. If you observe a substantial voltage spike when the light is switched off, it strongly suggests that inductive kick is the primary cause. 2. Inspect all neutral connections. Meticulously check the tightness of every neutral connection within the circuit. This includes connections at the electrical panel, the light fixture itself, and all the receptacles on the circuit. Ensure that all neutral wires are securely crimped or screwed into their respective terminals. 3. Test for ground faults. Employ a ground fault circuit interrupter, GFCI, to rigorously test for ground faults in the circuit. A GFCI is designed to trip immediately upon detecting a ground fault, thereby indicating a potential safety hazard that needs to be addressed. 4. Consider upgrading the equipment. If the issue is indeed due to inductive kick, a solution may involve replacing the fluorescent light fixture with an LED alternative. LED fixtures typically do not produce the same kind of voltage spikes. Additionally, newer electrostimulus machines are often designed to be less susceptible to voltage fluctuations. Therefore, upgrading to a newer model could also mitigate the problem. To summarize, the first step is to advise your friend to have a qualified electrician thoroughly diagnose and rectify any loose neutral connections or ground faults that may be present. Then consider replacing the existing fluorescent light with an LED fixture. This can significantly reduce or eliminate the inductive kick. If the problem persists even after these steps, contact the manufacturer of the electrostimulus machine. Inquire about its compatibility with the electrical circuit and whether any upgrades or modifications are recommended for safer and more reliable operation. Addressing these potential causes systematically should lead to a safer environment. Let's delve deeper into each of these potential causes and solutions. Inductive kick is a phenomenon that occurs when an inductive load, such as the ballast in a fluorescent light fixture, is suddenly switched off. The ballast contains a coil of wire, and when current flows through this coil, it creates a magnetic field. When the current is interrupted, the magnetic field collapses, inducing a voltage spike in the circuit. This voltage spike can be several times higher than the normal operating voltage, and it can damage sensitive electronic equipment. The magnitude of the inductive kick depends on several factors, including the inductance of the ballast, the current flowing through it, and the speed at which the current is interrupted. Older fluorescent light fixtures often use magnetic ballasts, which are more prone to producing inductive kick than newer electronic ballasts. The older electrostimulus machine may be more susceptible to damage from inductive kick because it may not have adequate surge protection. Surge protection devices, such as surge suppressors, are designed to absorb voltage spikes and prevent them from reaching sensitive equipment. These devices typically contain metal oxide varistors, MOVs, which are voltage-dependent resistors that conduct current when the voltage exceeds a certain threshold. When a voltage spike occurs, the MOV divert the excess current to ground, protecting the equipment from damage. A loose neutral connection is another common cause of electrical problems. The neutral wire is the return path for current in an electrical circuit, and it is typically grounded at the service panel. If the neutral connection is loose or corroded, it can create a high resistance path for current to flow. This can cause voltage imbalances in the circuit, as well as overheating of the wiring and equipment. When the light is turned off, the load on the neutral conductor is reduced, which can exacerbate the voltage imbalance. In a 120 volts/240 volt split-phase electrical system, the neutral wire is supposed to carry only the unbalanced current between the two 120 volts legs. If the neutral connection is loose, the voltage on one leg may rise while the voltage on the other leg drops. This can cause sensitive electronic equipment to malfunction or be damaged. A ground fault occurs when current flows from a live conductor to ground through an unintended path. This can happen if the insulation on a wire is damaged or if a piece of equipment is not properly grounded. Ground faults can be dangerous because they can cause electrical shocks and fires. A GFCI is a safety device that is designed to detect ground faults and quickly interrupt the flow of current. GFCIs work by monitoring the current flowing through the hot and neutral wires in a circuit. If there is a difference in current between the two wires, it indicates that current is flowing to ground through an unintended path. When a GFCI detects a ground fault, it trips a circuit breaker, cutting off the power to the circuit. GFCIs are typically installed in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor receptacles. Upgrading the fluorescent light fixture to an LED fixture can eliminate the inductive kick. LED fixtures do not use ballast, so they do not produce voltage spikes when they are turned off. LED fixtures are also more energy efficient than fluorescent fixtures, and they have a longer lifespan. Newer electrostimulus machines may be less susceptible to voltage fluctuations because they may have better surge protection or voltage regulation circuitry. Voltage regulation circuitry is designed to maintain a constant voltage output even when the input voltage fluctuates. This can help to protect the equipment from damage caused by voltage spikes or sags. The electrician should check the following. 1. The voltage at the receptacle with the light on and off, noting any voltage spikes. 2. The tightness of all neutral connections at the panel, light fixture, and receptacles. 3. For ground faults using a GFCI tester. They will also consider replacing the fluorescent light with an LED fixture to minimize inductive kick. If the issue persists, contacting the electrostimulus machine manufacturer about circuit compatibility or potential upgrades is wise. Now let's talk about the NEC, or National Electrical Code, requirements related to this situation. While there isn't one specific section that directly addresses inductive kick, several articles and sections are relevant to ensuring electrical safety and proper installation, which can mitigate the effects of such issues. NEC Article 110.3. The covers examination, identification, installation, and use of equipment. This section emphasizes that electrical equipment must be installed and used according to the instructions included in the listing or labeling. In the context of the electrostimulus machine and the lighting fixture, this means ensuring that both devices are used within the specified voltage and current ratings. It also highlights the importance of following manufacturer instructions for proper installation, which can help prevent issues related to voltage fluctuations. NEC Article 200 addresses the use and identification of grounded conductors, commonly known as the neutral wire. Section 200.2 specifically requires that the neutral conductor be insulated and identified properly. It also mandates that the neutral conductor be connected to a grounding electrode system, ensuring a low impedance path for fault current. In the scenario described, a loose neutral connection can cause voltage imbalances and shocks. Therefore, ensuring a solid and reliable neutral connection is crucial for safety and compliance with NEC requirements. NEC Article 210.8 covers ground fault circuit interrupter, GFCI protection for personnel. This section mandates GFCI protection in dwelling units in various locations such as bathrooms, kitchens, and outdoor areas. While a physical therapy office may not fall under the dwelling unit category, the principle of GFCI protection is highly relevant. GFCI protection is designed to de-energize a circuit quickly when a ground fault is detected, reducing the risk of electrical shock. In the context of an electrostimulus machine where patients are directly interacting with electrical equipment, GFCI protection can provide an added layer of safety. NEC Article 250 outlines the requirements for grounding and bonding. Proper grounding and bonding are essential for creating a safe electrical system. Grounding ensures that non-current carrying metal parts of equipment are connected to earth, providing a path for fault current to flow back to the source. Bonding ensures that all metal parts are electrically connected, minimizing voltage differences and reducing the risk of electric shock. In the case of the electrostimulus machine, proper grounding and bonding can help mitigate the effects of voltage fluctuations and reduce the potential for electrical shock. NEC Article 300.11 covers securing and supporting wiring methods. This section requires that wiring be securely supported to prevent damage and ensure reliable connections. Loose or unsupported wiring can lead to damaged insulation and loose connections, increasing the risk of electrical problems. Ensuring that all wiring is properly supported and secured can help prevent issues related to voltage fluctuations and electrical shock. NEC Article 314 covers outlet boxes, device boxes, and conduit bodies. This section outlines the requirements for the installation of boxes and conduit bodies, including proper support and secure connections. Ensuring that boxes and conduit bodies are properly installed can help prevent loose connections and other electrical problems. NEC Article 400.8 restricts the use of flexible cords and cables in certain applications. Flexible cords and cables are not permitted to be used as a substitute for fixed wiring of a structure, were run through holes in walls, structural ceilings, suspended ceilings, trot ceilings, or floors, were run in raceways, or were attached to building surfaces. This is relevant because improper use of flexible cords can lead to damage and electrical hazards. NEC Article 410 covers luminaires, lamp holders, and lamps. This article provides requirements for the installation of lighting fixtures, including proper wiring, support, and grounding. In the context of the fluorescent light fixture, it's important to ensure that it is installed in accordance with NEC requirements to minimize the risk of electrical problems. NEC Article 600 covers electric signs and outline lighting. While this article may not be directly applicable to the physical therapy office, it's relevant to note that electrical signs and outline lighting must be installed in accordance with specific requirements to ensure safety. This highlights the importance of following NEC guidelines for all electrical installations. NEC Article 680 covers swimming pools, fountains, and similar installations. While this article may not be directly applicable to the physical therapy office, it's relevant to note that swimming pools, fountains, and similar installations have specific electrical requirements to ensure safety. This further emphasizes the importance of following NEC guidelines for all electrical installations, particularly in areas where there is a high risk of electric shock. So, in summary, while there is no single NEC section that explicitly addresses inductive kick, several articles and sections are relevant to ensuring electrical safety and proper installation, which can help mitigate the effects of such issues. These include requirements for equipment installation, grounding, bonding, GFCI protection, and wiring methods. By adhering to these requirements, you can minimize the risk of electrical problems and ensure a safe environment for patients and staff. Remember, a qualified electrician should always be consulted for any electrical work to ensure compliance with the NEC and local codes. It is also important to consider the specific requirements for healthcare facilities, which may have additional regulations related to electrical safety. For example, the National Fire Protection Association, NFPA, publishes NFPA 99 Healthcare Facilities Code, which provides comprehensive requirements for electrical safety in healthcare facilities. It is advisable to consult with a qualified healthcare facilities engineer to ensure compliance with all the applicable codes and standards. Now, consider the voltage readings obtained during the inspection. The fluctuating voltage readings of 120 volts to 174 volts when the light is turned off are a significant indicator of an electrical problem. Normal voltage fluctuations are typically within a narrow range, such as plus or minus 5% of the nominal voltage, 120 volts. A voltage swing of this magnitude suggests a serious issue such as a loose neutral connection or a ground fault. A loose neutral connection can cause voltage imbalances in the circuit, as the voltage on one leg of the 120 volt/240 volt split phase system increases while the voltage on the other leg decreases. This can result in appliances and equipment being subjected to overvoltage or undervoltage conditions, which can damage them. A ground fault can also cause voltage fluctuations, as current flows through unintended paths to ground. This can create a voltage drop in the circuit, resulting in lower voltage readings. In addition to the voltage fluctuations, the electrical shocks experienced by patients are a clear sign of a dangerous electrical condition. Electrical shock occurs when current flows through the body, and even a small amount of current can be harmful or even fatal. The severity of the shock depends on several factors, including the amount of current, the path of the current through the body, and the duration of the shock. In the case of the electrostimulus machine, the electrical shocks are likely caused by a combination of voltage fluctuations and a ground fault. The voltage fluctuations can increase the potential difference between the machine and the patient, while the ground fault can provide a path for current to flow through the patient's body. Given the seriousness of the electrical problems, it is essential to take immediate action to correct the situation. The first step is to disconnect the electrostimulus machine from the electrical outlet and stop using it until the problem is resolved. Next, contact a qualified electrician to inspect the electrical system and identify the cause of the voltage fluctuations and electrical shocks. The electrician should perform a thorough inspection of the wiring, connections, and equipment in the circuit. They should also test for ground faults and voltage imbalances. Once the cause of the problem has been identified, the electrician can take corrective action to repair the electrical system. This may involve tightening loose connections, replacing damaged wiring, or installing a GFCI. After the repairs have been completed, the electrician should test the electrical system to ensure that it is safe and functioning properly. They should also verify that the voltage fluctuations have been eliminated and that there are no ground faults. Finally, it is important to educate staff about electrical safety and the proper use of electrical equipment. This can help to prevent future electrical problems and ensure the safety of patients and staff. In summary, the electrical shocks and voltage fluctuations are serious electrical problems that require immediate attention. Contact a qualified electrician to inspect the electrical system and make the necessary repairs. In the meantime, stop using the electrostimulus machine and educate staff about electrical safety.